In this video, you will learn the definite integral. The definite integral is actually the area under the graph. To find the area, we need to find the sum of the areas above the x-axis and under the graph. This is the graph, this one. This is the x-axis. Under the graph, above the x-axis, A2, minus above the graph, under the x-axis. So this is the x-axis, above the graph, so this area. This is the axis, above the graph, so this area. So A2 minus A1 minus A3. Or you can find the integration from 0 to 5 of the function fx. How to find the definite integral? First fundamental theorem of calculus. If f is continuous, it should be continuous. If you have a function like this, on the interval a, b, it is continuous. This one is continuous. If your function is like this, a, b, you have something like this. This one is discontinuous, for example. And capital F, which is the antiderivative of f on AB, then the definite integral, because you have the limit now from a to b of the function, is equal to the antiderivative, substitute b, minus antiderivative, and you substitute a. Consider 1 over x squared. The limit is from minus 1 to 4. This is a rational function. The graph is like this. 1 over x squared does not exist when x is equal to 0. In here, it is undefined. Since f must be continuous, and here the function is discontinuous at x equal to 0, and we need to find the definite integral from minus 1 to 4, this area, so it is not integrable. This definite integral is undefined. Example, the limit is 1 to 2, the function is x, so this one is equal to, first find the indefinite integral, the antiderivative, so x, this one is power 1, x is power 1, so 1 plus 1 equal to 2 over 2, and then the limit 1 to 2, so this one is equal to, one is f2, the other one is f1, 2 square over 2, this one from here, minus 1 square over 2, 1 square over 2, this one from here. So this is equal to 4 over 2 minus 1 over 2 equal to 3 over 2. We want to use the first fundamental theorem of calculus to compute this definite integral. Now we have two components, 9 and x squared. First find the antiderivative of 9 minus x squared. So we get 9x minus x cubed over 3. The limit is 0, 3. Substitute 3 into the antiderivative. We get 9 times 3 minus 3 cubed over 3 minus, this is the first one, FB. This is your FB. Minus, substitute the second x here, the lower limit, into the antiderivative. So we get 9 times 0 minus 0 cube over 3. This is your FA. If you solve this, 9 times 3 is 27. 3 power 3, 27 over 3 minus 0 minus 0 is 0. This is equal to 27 over 3 is 9. 27 minus 9 is 18. Now we have a trigonometric function, secant square x. We need to compute this definite integral. First, find the antiderivative for secant square. The antiderivative for secant square x is tangent x, because the derivative of tangent x is secant square x. You don't have to put plus c, because now we are talking about definite integral. We have the limit. So the limit is 0 pi over 3. Remember, the unit is always radian. Make sure that you set your calculator to mode radian, mode R. This one, tangent pi over 3 minus tangent 0 equal to sec 3. Tangent 0 is 0 equal to sec 3. If you use your calculator, you will not get sec 3, but it's okay. In order to get sec 3, you have this triangle. And here is pi over 6, pi over 3, 60 degree, 30 degree, 1, 2, this one, sec 3. So tangent is opposite, divide by 1, sec 3 over 1. From here also you can find sine and cos. Sine pi over 3 is sec 3 over 2, sine pi over 6 is 1 over 2, and so on. To compute a definite integral that has the same lower and upper limit. If you have the same value of lower and upper limit, for example, in this case 1 and 1, the answer must be 0. If you want to work this out, this one is x cubed over 3. Whatever the function here is, if you have this one 1, this one 1, it's going to be 1 over 3 minus 1 over 3. So, if you substitute the value into x, you will have the same thing. That's why you get 0. In this problem, you have the upper limit is greater than the lower limit. It is not normal. It should be 0, 4. But in this case, you have 4 to 0. So you cannot find the definite integral. What you need to do is, first, to change the position of 4 and 0. 0 should be the lower limit and 4 should be the upper limit. Since you change the position, you need to add a negative sign. Because you change the position, you add negative. The rest is the same. Remember, AB is equal to negative BA. So this one is equal to minus x square over 2 from 0 to 4 equal to negative 4 square over 2 minus 0 square over 2. So this one is equal to minus 8. Suppose that you have a piecewise function. Fx is equal to x square if x less than 2, 3x minus 2 if x greater than or equal to 2. This is your 2. So in here is x square, and in this area is 3x minus 2. So this one is x less than 2, this one is x greater than. Compute the definite integral from 0 to 6. So 0 is somewhere here and 6 is somewhere here. This one is 6. It means that you have two different functions. One is this one and the other one is this one. How to compute the definite integral? What you need to do is to separate this definite integral into 2. Why 2? Because you have two different rules here. Two different conditions. For x less than 2, fx is equal to x square. For x greater than 2, fx is equal to 3x minus 2. So what we can do now is, one is, we start from 0, is 0 until 2. So 0 until 2, this one, is x square. Plus, the other one is 2 to 6. Why 6? Because the upper limit is 6. Why we start at 0? Because the lower limit is 0. The function from 2 to 6 is 3x minus 2. Now we can solve this one. So this one is equal to x cubed over 3 from 0 to 2, and this one is equal to 3x square over 2 minus 2x from 2 to 6. First one is equal to 8 over 3 minus 0, this one, plus this one is 42 minus 2. And if you solve this, the answer is equal to 128 over 3. Remember, if you have the lower limit 0, this one should start with 0. In here, you have 2, so it should go to 2. And then we continue again at 2. 0 to 2, 2 to, we stop at 6 because the upper limit is 6. So 0 to 6 is equal to 0, 6.